The James Webb Space Telescope can see light that left its source before the Earth even existed, and that is not some poetic exaggeration, it is just basic astronomy doing what it does. Scientists built this telescope to look far back in time, but almost nobody on the team actually expected it to find fully grown, fully formed galaxies staring back at them from an era when the universe was supposed to be dark, empty, and still cooling down. Stick around, because what Webb found in its very first year broke a timeline that astronomers had trusted for almost 30 years. Before we go any further, if the idea of a machine rewriting the history of everything sounds like your kind of rabbit hole, hit subscribe now so the next mind-bending discovery from this telescope lands in your feed the moment scientists confirm it. Here is the strange part. Webb was not supposed to be controversial. It was supposed to be a bigger, sharper version of the Hubble Space Telescope, something that would confirm what we already believed about how the universe grew up. Instead, within its first few months of operation, it started sending back pictures of galaxies that looked too old, too big, and too organized for the young universe they were sitting in. Astronomers were not just surprised, some of them were genuinely rattled, because a galaxy that looks like it should not exist yet is not a small detail. It is a crack in the foundation. And that crack is exactly where this story lives. Not in a science fiction plot, but in real data, from a real telescope, orbiting nearly 1 million miles from where you are sitting right now. Over the next several minutes, we are going to walk through what Webb actually found, why it terrified some of the smartest people in astronomy, and what it means for how small, or how large, our place in all of this really is. Now let us start from the beginning. Most people assume the James Webb Space Telescope is basically just an upgraded Hubble, a fancier camera that takes prettier photos of space. That is actually wrong, and the difference matters a lot for this story. Hubble mostly captures visible light, the same kind of light your eyes can see. Webb was built to capture infrared light, which is heat radiation, invisible to human eyes, but incredibly good at traveling across vast stretches of space without getting blocked by dust. That difference sounds small, but it is the entire reason Webb can see further back in time than any telescope before it. As light travels across the expanding universe, it gets stretched out, the same way a siren sounds lower in pitch as an ambulance drives away from you. Visible light from extremely distant galaxies gets stretched so much that by the time it reaches us, it is no longer visible at all. It is shifted into the infrared. Hubble simply cannot see most of it. Webb was built specifically to catch that stretched-out ancient light, which means Webb was always going to be a time machine, just not the kind anyone expected. Think of it this way. If you shine a flashlight at a wall right next to you, the light barely has time to change at all before it hits the wall. But if that same beam of light had to travel across an ocean, bend around storms, and stretch through decades of moving air, it would arrive looking completely different from how it started. That is roughly what happens to light crossing billions of years of an expanding universe. It leaves a young, hot, blue burning star, and by the time it finally reaches a mirror near Earth, it has stretched so far into longer wavelengths that only an infrared detector, like Webb's, can catch it at all. Every image this telescope produces is really a translation, converting invisible heat signatures back into a picture we can actually look at and understand. The first surprise came almost immediately. In July 2022, just weeks after Webb released its first official images, a team led by astronomer Rohan Naidu at the Massachusetts Institute of Technology spotted a galaxy that appeared to exist just 300 million years after the Big Bang. For comparison, the universe is about 13.8 billion years old, so this galaxy showed up when the universe was barely 2% of its current age. Scientists expected to see faint, messy, barely formed clumps of gas at that distance, something closer to a cosmic toddler. What they actually found instead was a surprisingly bright, surprisingly structured galaxy, the kind you would expect from a much older universe. It was like opening a box expecting to find a newborn and instead finding a kid already riding a bike. That comparison might sound casual, but the science behind it is not. A galaxy that bright, that early, means stars had to form, live out much of their lives, and collect into an organized structure far faster than any existing model predicted. Astronomers had spent decades building computer simulations of how galaxies grow, based on the gravity of dark matter, the slow collapse of gas clouds, and the birth of the first stars. Those simulations simply did not have room for a galaxy this developed, this early. It was the astronomical equivalent of finding a fully grown oak tree in a forest that was planted last week. Here is a small comparison to help this land. The camera on Webb that captured that ancient galaxy runs on roughly the same amount of power as a couple of household light bulbs, tiny compared to the scale of what it is doing. And yet, with that modest amount of power, sitting nearly 1,000,000 miles from Earth, it photographed light that had been traveling toward us for over 13 billion years, longer than our solar system has even existed. Something that small, doing something that large, is part of why this story feels almost impossible, even though every part of it is real. It helps to picture the actual mechanics for a second. Somewhere out past that ancient galaxy, a handful of photons, tiny particles of light, broke away from a burning cluster of newborn stars. They traveled through empty space for so long that entire other galaxies formed, grew old, and changed shape while those particular photons were still mid-journey. They crossed distances that would take a modern jet plane longer than the age of the universe itself to cover. And then, after all of that traveling, after outlasting nearly everything else in their path, a tiny fraction of them happened to land on a gold-coated mirror built by engineers on a small blue planet that did not even exist when the journey began. That is not poetry. That is simply what happened, measured, confirmed, and published. Before we go further, here's a question for you. If you had access to a telescope that could look back to the beginning of time, what era would you point it at first? Drop your answer in the comments, because it genuinely helps me figure out which parts of deep space history you want covered next on this channel. Let us keep going, because the first galaxy was only the beginning of the problem. The second finding changed everything scientists thought they understood about how fast galaxies could grow. In February 2023, a research team working with data from Webb, including scientists at Pennsylvania State University, identified a group of candidate galaxies that appeared to exist somewhere between 300 and 500 million years after the Big Bang. That part alone was not shocking anymore. Astronomers were starting to expect early galaxies by then. What shocked them was the size. Some of these galaxies looked like they already contained as much stellar mass, meaning the combined weight of all their stars, as our own Milky Way galaxy contains today, after 13 billion years of growth. To put that in a scale you can actually picture, imagine your entire life savings appearing in your bank account within the first week of your first job, decades ahead of any reasonable timeline. The math simply should not work that quickly, and yet the light Webb captured suggested that in some cases, it did. Scientists nicknamed these objects universe breakers, half joking, half serious, because if the numbers held up, they would break the standard model of how galaxies form. Researchers went back and checked their math constantly, because that is what good scientists do when the universe hands them something that looks impossible. Some of the extreme mass estimates were later revised downward, since bright, compact galaxies can sometimes be mistaken for more massive ones than they really are. But even after the corrections, several of these early galaxies remained stubbornly, uncomfortably large for their age. This is where the domestic and the cosmic collide in a strange way. On one hand, you have galaxies containing hundreds of billions of stars, spread across distances so vast that light takes billions of years just to cross them. On the other hand, the actual signal Webb receives from all of that is fainter than the glow from a nightlight plugged in a room several miles away. The telescope is essentially listening for a whisper from the edge of everything, and somehow it is catching enough of that whisper to measure how much a galaxy weighs. It helps to understand just how underestimated this whole project was before it ever launched. When Webb was first proposed in the 1990s, many scientists doubted it would ever fly. The telescope's mirror, made of 18 hexagonal gold-coated segments, had to unfold perfectly in space, with over 300 single points of failure, any one of which could have ended the mission instantly. Budgets ballooned, launch dates slipped year after year, and by the mid-2000s, some astronomers privately referred to it as the telescope that eats budgets and never flies. It was mocked, delayed, nearly canceled more than once, and treated by some critics as an oversized, overpriced experiment that would never deliver results worth the cost. Then, on Christmas Day in 2021, it launched from French Guiana on an Ariane 5 rocket, and over the following month it unfolded itself piece by piece, nearly 1 million miles from Earth, with no astronauts nearby to fix it if something went wrong. Every one of those 300-plus failure points worked. Engineers at NASA and the European Space Agency, along with teams at the Space Telescope Science Institute in Baltimore, watched a project that had been doubted for over 2 decades succeed on the very first try. The underdog telescope that almost never left the ground became the tool that broke the record for the most distant galaxy ever confirmed, not once, but multiple times within its first 2 years. Would you share this video with someone who still thinks space exploration slowed down after the moon landing? A lot of people genuinely have no idea how much is happening right now, and sharing this helps the story reach people who would actually find it fascinating. Let us talk about exactly how astronomers confirm that a galaxy is as old and as far away as they claim, because the third discovery puzzled scientists the most, not because of what it showed, but because of how hard it was to prove. Distance in astronomy is measured using something called redshift, a number that describes how much a galaxy's light has stretched on its journey to us. The more the universe has expanded during that journey, the more the light stretches, and the higher the redshift number climbs. In May 2023, a team led by astronomer Brant Robertson at the University of California, Santa Cruz confirmed a galaxy nicknamed JADES-GS-Z13-0 sitting at a redshift of 13.2, corresponding to a time just 325 million years after the Big Bang. Later, in 2024, an even more extreme galaxy was confirmed at a redshift above 14, pushing the boundary back to roughly 290 million years after the beginning of everything. These are not rough estimates anymore. These numbers come from spectroscopy, a technique that splits incoming light into its individual wavelengths, the same way a prism splits sunlight into a rainbow, allowing scientists to measure the exact stretch in the light and calculate distance with startling precision. Here is what puzzled researchers the most about that particular find. Based on existing models, a galaxy at that age should barely be glowing, a faint smudge of newly forming stars. Instead, this galaxy showed clear signs of already containing heavier elements, meaning previous generations of stars had already lived, exploded, and seeded the surrounding gas with new material. That process usually takes hundreds of millions of years to happen even once. Finding evidence that it may have already happened multiple times, this early, felt like discovering a toddler who already had gray hair. Scientists expected a nearly empty nursery. What they actually found was evidence of at least one full generation of stellar life and death already completed. The compressed comparison researchers use is this. It is like arriving at a construction site expecting to see the foundation being poured, and instead finding a building that has already been lived in, renovated, and passed down to a second owner. This is a good moment to pause and be honest with you, the way good scientists are honest in their own papers. Scientists will tell you they do not fully understand this yet. The current leading explanation is that star formation happened in short, extremely intense bursts in the early universe, rather than the slow, steady pace we see in galaxies today, possibly because there was more raw gas available and less competition for it. But that explanation is still being tested, refined, and in some cases openly debated at astronomy conferences. Some researchers think our models of early star formation are simply incomplete. Others think a small number of these bright early galaxies might be more common, or less massive, than first believed, once more data comes in. Nobody is claiming a final answer yet, and that uncertainty is actually one of the most honest, most human parts of this entire story. While all of this debate continues, it helps to zoom out to the actual physical scale of what Webb is doing every single day. The telescope sits at a location nearly 1 million miles from Earth, called the second Lagrange point, a spot where the combined gravity of the Earth and the Sun lets a spacecraft essentially hover in a stable position relative to both. From there, Webb's main mirror, spanning about 21 feet across, roughly the width of a small living room, gathers light that started its journey before our Sun, our planet, and every living thing on it ever existed. And yet, the temperature control on this enormous, ancient, light-gathering machine depends on a sunshield about the size of a tennis court, kept in constant shadow, cooling the telescope's instruments down to nearly negative 370 degrees Fahrenheit, colder than nearly anywhere naturally found on Earth. That is roughly the temperature difference between the inside of your freezer and the surface of the sun, except pushed to an extreme most household appliances could never survive. A tennis court-sized shield, keeping instruments colder than any freezer on the planet in order to detect heat signatures from the dawn of time. That is the strange, oddly domestic engineering holding up one of the most cosmic discoveries in modern science. Here's something worth thinking about while we keep going. Has anything in this video so far actually changed how you picture the early universe? If this is shifting your mental image even a little, tap like on this video and let the channel know, because that tells the platform this kind of deep, detailed science story is worth showing to more people like you. Let us bring this back to what these discoveries actually mean for the bigger picture, because the implications reach further than just a handful of unusually early galaxies. If galaxies really can form this fast, this massive, this early, then astronomers may need to rethink how dark matter, the invisible substance that makes up most of the universe's mass, actually clumps together to seed galaxy formation in the first place. Dark matter does not emit light, does not interact with normal matter in obvious ways, and can only be detected through its gravity. Current models assume dark matter clumps form gradually, slowly gathering enough gas and dust to spark galaxy formation over hundreds of millions of years. But if fully formed, heavy galaxies are showing up within the first 300 million years, that gradual timeline gets seriously squeezed. Some researchers, including scientists publishing through Nature Astronomy in 2023, have proposed that early star formation may have been far more efficient than current models allow, meaning a much higher percentage of available gas converted into stars, much faster than anyone expected. Others have proposed that early black holes may have played a bigger role earlier than believed, actually helping trigger and accelerate star formation in their host galaxies, rather than only forming after galaxies were already mature. Speaking of black holes, this is actually where one of Webb's strangest discoveries comes in. In late 2023, astronomers using Webb data identified a supermassive black hole inside a galaxy existing just around 470 million years after the Big Bang, a black hole already weighing millions of times the mass of our Sun. Researchers, including a team publishing findings connected to work at the University of Cambridge, described this as another universe-breaker moment, because black holes that massive are supposed to take an extremely long time to grow, gradually consuming gas and merging with other black holes over billions of years. Finding one already fully grown, this early, felt like finding a business already running at full scale, employees, revenue, offices, and everything, within its very first month of opening its doors. The expectation was a small, struggling startup. What researchers actually found was already a fully functioning empire. And the compressed comparison scientists use here is blunt. Something that should take billions of years to build had somehow assembled itself in less than 500 million. Astronomer Akash Bogdan, who worked on identifying this early black hole through a combination of Webb data and X-ray observations, described the discovery as forcing a serious rethink of how the very first black holes might have formed. Possibly not from the slow collapse of dying stars at all, but from the direct, sudden collapse of enormous, unstable clouds of primordial gas, skipping several intermediate steps that older models assumed were required. If that theory holds up under further testing, it would mean some black holes were never small to begin with. They may have been born massive, in a single dramatic collapse, rather than earning their size gradually over cosmic time, the way textbooks have long described. There is something almost unsettling about that idea, if you sit with it for a moment. We tend to picture growth as something earned, slowly, star by star, merger by merger, year by year. But the early universe may have occasionally skipped that process entirely, producing monsters in a single generation instead of many. It is a little like discovering that some rivers do not form from centuries of slow erosion, but instead appear suddenly, fully carved, after a single catastrophic flood. There is a fourth discovery worth walking through here, because it puzzled scientists in a completely different way than the others, not through size or mass, but through sound, or more precisely, the complete absence of it. In 2023, a team analyzing Webb data on a distant galaxy cluster noticed something odd about the light bending around it. Massive objects in space bend light through gravity, a phenomenon called gravitational lensing, and astronomers use that bending like a natural magnifying glass to see galaxies that would otherwise be too faint and too far to detect at all. Using that lensing effect, researchers spotted a galaxy so faint, so young, and so quiet in its star formation that some scientists initially assumed the data was an instrument error. It was not glowing brightly like the universe breakers found elsewhere. It was dim, patchy, and almost hesitant, the kind of early galaxy scientists had originally expected to find everywhere, before the bright, oversized ones started stealing the headlines. In a strange way, this quiet, ordinary-looking galaxy became just as important as the extreme ones, because it proved the early universe was not uniformly overachieving. It was a mixed and messy nursery, some galaxies racing ahead, others barely getting started, much like siblings growing up in the very same house at very different speeds. That sensory contrast matters more than it might seem. Picture the difference between standing near a bonfire, hearing it crackle, feeling the heat push against your face, versus standing near a single dying candle in a cold room, watching the flames struggle to stay lit. Webb found both kinds of galaxies existing at nearly the same moment in cosmic history, blazing bonfires and struggling candles, scattered unevenly across the early dark. That unevenness is now considered one of the most important clues for figuring out why some early galaxies grew so unexpectedly fast, while others barely got off the ground. None of this means the Big Bang theory is wrong, and it is worth being clear about that, because headlines sometimes make it sound more dramatic than it actually is. The overall framework, an expanding universe that began roughly 13.8 billion years ago from an extremely hot, dense state, remains supported by an enormous amount of independent evidence, from the cosmic microwave background radiation to the observed expansion rate of galaxies. What is actually being challenged is not whether the universe began that way, but how quickly structure, stars, galaxies, and black holes were able to organize themselves once it did. That distinction matters because it is the difference between rewriting a book and correcting a chapter. Scientists are not throwing out everything they know about cosmology. They are recognizing that the opening chapters of the universe's story happened faster, messier, and more dramatically than the outline they had been working from. And if you think about your own life for a second, some of the most important years of growth often happen in short, intense bursts, rather than slow, steady progress. A growth spurt, a crash course, a sudden opportunity. It turns out the universe itself may have gone through something similar in its earliest moments. One last question before we close this out. Have you ever had a moment in your own life where something grew, changed, or came together far faster than anyone expected, the way these early galaxies did? Leave a comment describing it if you're willing, because it genuinely helps connect these massive cosmic ideas to something real and human, and I read every single one. So where does all of this leave us? A telescope nearly 1,000,000 miles away, cooled colder than any freezer on Earth, staring backward through nearly the entire history of everything, has found galaxies too big, too early, and too organized for the story we thought we understood. It has found black holes already running at full scale before they should have even opened their doors. It has found evidence of stars living and dying in generations, in a universe barely old enough to have finished its first breath. Few people realize just how close we are, right now, to watching a fundamental scientific model bend in real time. Most of us go through our days assuming the big questions, how the universe began, how everything got here, were settled decades ago in some textbook we half remember from school. But the truth is messier, and honestly, more exciting than that. Right now, in observatories and universities across the world, in places like the Space Telescope Science Institute, Cambridge, Santa Cruz, and dozens of others, real scientists are staring at real data that does not fully fit, and instead of hiding that, they are publishing it, debating it, and chasing it further. That is the flip side of where we started. We opened with a telescope seeing something impossible, a galaxy older than the model allowed. We close with the understanding that impossible was never really the right word. It was only unexpected, and unexpected is simply what happens at the edge of what we currently know. Every generation of scientists eventually reaches that edge, finds it more crowded, more alive, and more surprising than they assumed, and then quietly redraws the map. The universe is not distant from you the way it feels distant. The light Webb captured from those ancient galaxies is not a photograph of somewhere else. It is a photograph of somewhere else's past, arriving here, now, at this exact moment, into an instrument built by people who almost gave up on it more than once. That light traveled for over 13 billion years to reach a mirror the width of a small room, floating in the cold dark near your own planet, just so a handful of scientists, and now you, could look at it and ask a better question than the one we started with. Somewhere out past the edge of what any model predicted, a galaxy that should not exist yet is quietly, steadily, burning anyway. We do not fully understand it yet. Maybe we are not supposed to, not all at once, but it is out there, right now, still glowing, still waiting for the next telescope, the next scientist, the next question, to catch up to it. And here is the part that is easy to miss in all the numbers and all the names. None of this required a spaceship full of astronauts, or a mission to some far-off planet, or anything close to the plot of a movie. It required a mirror the size of a small room, a shield the size of a tennis court, and enough patience from thousands of engineers to wait through decades of doubt, delays, and near cancellations. The most distant thing humans have ever confirmed was found not by traveling to it, but by simply learning how to listen for a whisper that had already been traveling toward us the entire time. That is worth sitting with for a second. The light was always coming. It left its source before our planet existed, before the sun had finished forming, before anything we would recognize as home was even possible. And it kept moving, patiently, silently, for over 13 billion years, completely indifferent to whether anyone would ever be there to receive it. We just happened to build something at exactly the right moment in our own short history, capable of finally catching it. So the next time you look up at a clear night sky, remember that almost everything you can see with your own eyes is relatively close, cosmically speaking, a local neighborhood of stars inside one ordinary galaxy. The truly ancient light, the galaxies that should not exist yet, the black holes that grew up too fast, all of that is invisible to us without help, sitting quietly behind the visible sky like a much older, much stranger story hiding just out of view. We used to think the beginning of the universe was slow, gradual, almost gentle, gas cooling, stars slowly igniting one by one over hundreds of millions of patient years. Now we understand it was closer to a fever, fast, chaotic, uneven, producing both bonfires and dying candles side by side within the very same few 100 million years. Few people walking around today realize just how recently that entire picture changed, in the space of only a couple of years, thanks to one telescope, one mirror, one very patient piece of engineering finally doing the job it was built for. But we all share the sky it was pointed at. We all live inside the same expanding story that produced those impossible early galaxies, whether we think about it on a random Tuesday or not. The universe did not save its strangest chapter for some distant future discovery. It already happened, billions of years ago, and the evidence has been quietly crossing the dark this entire time, waiting for a mirror cold enough and patient enough to finally catch it. Somewhere, right now, more of that light is still arriving. More of it is still crossing the last few miles of its impossibly long journey, heading toward a small, gold-coated mirror floating silently near our own tiny corner of everything. We do not know yet what it will show us next. Nobody does. That is not a weakness in the science. That is the whole reason to keep watching.